Welcome to the session on evaluation of double integrals using numerical methods. In the numerical integration, we already discussed the trapezoidal rule of numerical integration. In many applications, there may be problems to evaluate the double integrals using numerical methods. Trapezoidal rule can be used to evaluate double integrals with constant limits of integration. For this, the double integrals can be considered as nested one-dimensional definite integrals. Let us consider the double integral I is equal to double integral a to b and c to d f of xy dx dy, where the region of integration is the area bounded by the lines x equal to a, this is the line x equal to a, x equal to b, y equal to c and y is equal to d. We want to evaluate this double integral over this region. This is the region of integration. Now, in order to apply the trapezoidal rule, the truncation error in the value of definite integral can be reduced by taking the length of the interval of integration small. In view of this, we divide the total rectangular area of integration into smaller rectangles like this, each of dimensions h and k. Now, evaluate the double integral over each of the sub-rectangles. In order to evaluate this double integral, first we evaluate the double integral on each of these rectangles and add them to get the value of the given double integral. After integrating over all these small rectangles, we add the integrals in order to get the required double integral. Here, consider these four rectangles whose corner points are A, C, E and G, and we split this region into smaller rectangles. Then, let this point A be taken as xi yj. This is the point xi yj, and B be the point xi plus 1 yj, C be the point xi plus 2 yj, H be the point xi yj plus 1. The center point I is xi plus 1 yj plus 1. This point D is xi plus 2 yj plus 1. G be the point xi yj plus 2, F be the point xi plus 1 yj plus 2, and E be the point xi plus 2 yj plus 2. These are the points. Now, we consider one small rectangle ABIH. This is known as the representative subrectangle. Here, the width, this point is xi plus 1 yj, xi plus 1 yj. This is the point xi yj. I is xi plus 1, this is the point xi plus 1 yj plus 1. This is the point h be the point xi yj plus 1. Here, this difference, that is xi plus 1 minus xi, which is equal to h. We denote this difference by h, and along this y axis we take this difference yj plus 1 minus yj, let it be k. Now, let us apply the trapezoidal rule to find the double integral I equal to integral from yj to yj plus 1, integral from xi to xi plus 1, f of xy dx dy. That is the double integral over this small rectangle. By trapezoidal rule, we know that the value of integral I equal to integral from x0 to x1 f of x dx is h by 2 into y0 plus y1. This is from trapezoidal rule. We just derived this result in the session trapezoidal rule of integration. Here y0 is the value of the function y equal to f of x at x0 and y1 is the value of the function y equal to f of x at the point x1. Then the integral from x0 to x1 f of x dx is h by 2 into y0 plus y1, where h is the width of the interval. Therefore, we can write this double integral as this is equal to integral from yj to yj plus 1 into, now we apply the trapezoidal rule for this inner integral, which is h by 2 into f of xi, here the point is xi yj, and xi to xi plus 1 mean integral from a to b. The corresponding points are xi yj and xi plus 1 yj. Therefore, we can write the value of this integral by trapezoidal rule as h by 2 into f of xi y plus f of xi plus 1 y. This is the value of this inner integral by using the trapezoidal rule into dy. This is equal to integral from yj to yj plus 1. This h by 2 can be taken outside of this integral because h by 2 is a constant. Therefore, this can be taken outside. This is equal to h by 2 into integral from yj to yj plus 1 f of xi y dy plus integral from yj to yj plus 1 f of xi plus 1 comma y dy. This h by 2 is common for these two integrals. This is equal to h by 2 into, now we apply the we apply the trapezoidal rule for this first integral and then for this second integral also. From this we can write value of this integral is h by 2 is common, value of this integral is k by 2 into, here the length of interval is k, therefore, k by 2 into f of xi yj, f of xi yj plus f of xi yj plus 1. This is by the trapezoidal rule for this function. We can write integral yj to yj plus 1 f of xi y dy as k by 2 into f of xi yj plus f of xi yj plus 1 plus k by 2 into For this integral also we can apply the same rule. We can write value of this integral as k by 2 into f of x I plus 1 y j, f of x I plus 1 y j plus f of x I plus 1 y j plus 1. This h by 2 is common. This is equal to h into k divided by 4 into f of I comma j. We use the notation f of I comma j for f of x I y j, plus similarly we have to use the notation f of I plus 1 for this f of I plus 1 j. F I plus 1 j, not f of f I plus 1 j, I plus 1 comma j in the suffix, plus for this term we use the notation f of I comma j plus 1, plus for this we use the notation f of f I plus 1 comma j plus 1 in the suffix, where f of I comma j is f of x I y j. Which is equal to h into k divided by 4 into, here note that f I j means the value of the function f of x y at the point x I y j, that is at the point A. F I plus 1 comma j means the value of the function f of x comma y at the point x I plus 1 y j. F I comma j plus 1 mean the value of the function f of x y at the point x I y j plus 1, and f I plus 1 comma j plus 1 means the value of the function f of x y at the point x I plus 1 comma y j plus 1. All these points are the corner points of this subrectangle. Therefore, we can write this sum as sum of the values of the integrand f of x y, sum of the values of the integrand f of x y at the corner points of the subrectangle A B I H. The rectangle A B I and H. Now, we evaluate the double integral for this subrectangle B C D I like the previous evaluation. Then for the subrectangle I D E F, and then this subrectangle H I F G, and in order to get the required double integral value of the double integral, we add all these values, that is double integral f of x comma y over this rectangle A C E G dx dy, which is equal to integral from y j to y j plus 2, integral from x j to x j plus 2, f of x comma y dx dy. That is equal to, this can be written as integral from double integral over this rectangle ABIX, f of x comma y dx dy plus double integral over the rectangle BCDI f of x comma y dx dy plus double integral over this rectangle HIFG f of x y dx dy plus double integral over this rectangle IDEF f of x comma y dx dy. That is equal to HK by 4 into f of I comma j plus f of I plus 1 comma j plus f of I comma j plus 1 plus f of I plus 1 comma j plus 1. This is for this rectangle. Plus f of I plus 1 comma j for this rectangle BCDI. We can write the double integral over the rectangle BCDI as f of I plus 1 comma j plus f of I plus 2 comma j plus f of I plus 1 comma j plus 1 plus f of I plus 2 comma j plus 1 for f suffix I plus 2 comma j plus 1. These are the values of the function f of x y at these corner points B, C, D and I. Plus similarly for this rectangle HIFG, we can write the value of the double integral as f I comma j plus 1 plus f I plus 1 comma j plus 1 plus f I comma j plus 2 plus f I plus 1 comma j plus 2. These are the function values at these corner points H, I, F and G. Then for this last rectangle, we can write the value of the double integral as f I plus 1 comma j plus 1 plus f I plus 2 comma j plus 1 plus f I plus 1 comma j plus 2 plus f I plus 2 comma j plus 2. H into k divided by 4 is common. Therefore, this is equal to, we can write h into k divided by 4 into f I j, this term f I comma j plus f I plus 2 comma j, f I plus 2 comma j, this is the term, plus f I j plus 2, f I j plus 2, this is the point, and f I plus 2 j plus 2. Plus, here we can write 2 times f I plus 1 j, because here one f I plus 1 comma j and f I plus 1 comma j in this second term. Therefore, we can write 2 times f I plus 1 comma j plus 2 times f I j plus 1, f I j plus 1 here, and then f I j plus 1. Therefore, 2 times f I j plus 1 plus f I plus 2 j plus 1, f I plus 2 j plus 1 is here, and f I plus 2 j plus 1 is in this last term. Therefore, 2 times f I plus 2 comma j plus 1 plus f I 2 times f I plus 1 j plus 1, sorry, f I plus 1 j plus 2, here 1 f I plus 1 j plus 2, and in this last term there is 1 f I plus 1 comma j plus 2. Plus 4 times the remaining terms are f I plus 1 j plus 1, f I plus 1 j plus 1 is here, in the third term also f I plus 1 j plus 1, and in the last term f I plus 1 j plus 1. Therefore, 4 times f I plus 1 j plus 1. Which is equal to h into k divided by 4 . We can write this as h into k divided by 4 into sum of the values of the integrand f of x y at the corner points f I j, f I plus 2 j, f I j plus 2 and f I plus 2 j plus 2 are the values of the function f of x y at these corner points a, c, e and g. That is sum of the values of f of x y at the corner points a, c, e and g plus 2 times, here 2 times f I plus 1 j, f I j plus 1, f I plus 2 j plus 1 and f I plus 1 j plus 2 are the values of the function f of x y at the points b, d, f and h, where f I plus 1 j plus 1 is the value of the function f of x y at the center point I. Therefore, we write this first, that is plus 4 into value of the function at the center point I, and 2 into sum of the value of the function f of x y at the remaining points. This is the recurred double integral f of x y dx dy over this rectangle AC EG. This is the method of evaluating double integral using the trapezoidal rule of integration. Now, consider this example. Evaluate double integral from 0 to pi by 2 and pi by 2 to pi cos x plus y dx dy using the trapezoidal rule by taking h equal to k equal to pi by 4. The width of intervals are the same, both are pi by 4. Now, here the variation of x is from pi by 2 to pi and variation of y is from 0 to pi by 2. Therefore, we can consider this rectangle. The points are, A is the point 0, sorry, pi by 2 0, x is here pi by 2 and y is 0. B be the point 3 pi by 4 comma 0 because h is pi by 4, and C be the point pi comma 0. H be the point pi by 2 comma pi by 4. The center point is 3 pi by 4 comma pi by 4. This is the point I. Now D be the point pi comma pi by 4. This point is G. This is pi by 2 comma pi by 2. This is F. F be the point 3 pi by 4 comma pi by 2, and this corner point is E, which is pi comma pi by 2. Here the variation of x is from pi by 2 to pi, means pi by 2 to pi, all are pi by 2 to pi, pi by 2, 3 pi by 4 pi, and the variation of y is from 0 to pi by 2. Here y coordinate is 0, then pi by 2, 0, pi by 2 and 0 pi by 2. Now, by the trapezoidal rule, we can write value of this integral as h into k divided by 4, means here both are pi by 4. Therefore, pi by 4 into pi by 4 means pi square by 16 into value of sum of values of f of x y at these corner points, that is 0, minus 1 plus 0 plus 4 times value of f of x y at the center point. Here the function is f of x y equal to cos x plus y. Now, the corner points are pi by 2 comma 0. Cos pi by 2 plus 0 means cos pi by 2, that is 0. Similarly, at C, this is a corner point. C means the point pi comma 0, in which case cos x plus y is cos pi plus 0, that is minus 1. Similarly, for this E is a corner point and G also a corner point. The values are 0, minus 1 and 0. We add these values. Now, 4 times the value of the function f of x y at the center point. Center point is 3 pi by 4 comma pi by 4. Therefore, cos 3 pi by 4 plus pi by 4 means value is minus 1, 4 into minus 1 plus 2 times. Next is sum of values of f of x y at the remaining points. Remaining points are B, D, F and H. The corresponding function values are minus 1 by root 2, minus 1 by root 2, minus 1 by root 2 and minus 1 by root 2. All are minus 1 by root 2. Pi square by 16 is common, which is equal to, here h is pi by 4 and k is pi by 4, means h into k is pi square by 16 divided by 4 means this 16 into 4, that is pi square divided by 64 into. One simplification, we will get the value of this as 6 plus 4 root 2 minus of 6 plus 4 root 2, which is equal to negative 1.7976. This is the approximate value of the required double integral, that is minus 1 plus 7 minus 1.7976. With this example, let me conclude this session. Thank you for watching this session. Have a nice day.